Welcome to the story of the element girl Bismuth from family 15, also known as the nitrogen or the Pnictogen family with atomic number 83. For the dance production at our school, EXO brought her bag of cosmetics so we could experiment with different shades of nail polish, eyeshadow, and lipstick for the performance. EXO was passionate about makeup and curious about the elements involved in its creation. I pulled out my laptop and we discovered that bismuth is used in many cosmetics. Time to visit Bismuth, I said. Just then, I got a message from Albert. Hi, Atom. Can we visit Bismuth? My mom had an upset stomach for a couple of days and her doctor prescribed a certain medication. She's fine now, and it turns out the major ingredient in this medicine is a bismuth compound. What a coincidence, I thought. After school, EXO, Albert, and I gathered in my backyard under a large tree with my magical periodic table. Albert speculated that we might meet bismuth in a pharmaceutical factory, while EXO guessed it would be at a cosmetics company. Eagerly, we pressed on bismuth. The trees whirled above our heads and the leaves fluttered around us as we cried out in delight. Soon, we found ourselves inside our local pharmacy, standing in the cosmetics aisle. We noticed a girl in a colorful dress with a vibrant hairdo, deeply engrossed in trying out different shades of eyeshadow. I muttered, "Could that be bismuth?" "My thoughts exactly," EXO said aloud. "She has to be bismuth. She seems to really love cosmetics." The girl heard EXO and turned towards us with a wide smile on her face. "Hello there. Yes, I am Bismuth." In addition to her makeup, she wore a colorful hair barrette on her head. Her dress featured a golden top and a pink skirt that seemed oddly familiar. She also carried an interesting-looking handbag. EXO eagerly asked, "How is bismuth used in cosmetics?" Bismuth picked up an eyeshadow and said, "See the smooth, pearly finish? That is due to bismuth oxychloride, or BiOCl. This inorganic bismuth compound is a white, powdery substance with a lustrous, shiny appearance. It is added to cosmetics to give them a shimmery, smooth finish, whether it is eyeshadow, blush, or nail polish." I asked hesitantly, "Bismuth oxychloride must be safe, right?" Bismuth replied, "Bismuth has been known to humanity since ancient times. The rare, naturally occurring mineral, bismoclite, which has a white, shiny look, is bismuth oxychloride. The Egyptians used this for cosmetic purposes. People have known about bismuth since the 1400s. But it was often confused with other metals like lead and tin. It was only in 1753 that a French chemist, Claude Geoffroy the Younger, proved that bismuth was a completely different element. These days, bismuth is obtained as a byproduct during the processing of ores of metals such as lead, copper, and tungsten. In nature, bismuth is found as bismuth sulfide and bismuth oxide. During ore purification, bismuth is extracted as a byproduct, and then bismuth oxychloride is created artificially in a laboratory. It is crucial to ensure the purest form of bismuth is used and that impurities like lead are absent, as they can be harmful. So yes, bismuth oxychloride is safe when properly purified. However, it can pose issues for those with sensitive skin or allergies. Albert asked, "How did you get your name?" Bismuth answered, "Pure bismuth is a white, brittle substance that develops a faint pink tint upon oxidation. The Germans originally called me Bismuth, meaning white mass. This name eventually evolved into bismutum or bissima in Latin, which then became bismuth." Looking at Bismuth's hair barrette, Exo asked, "Your hair barrette is quite nice. Where did you get it?" Bismuth said proudly, "I made it by melting bismuth metal and cooling it slowly." When bismuth cools, it forms intricate geometric crystals with vibrant colors due to an oxide layer that develops on the surfaces during the cooling process. The size, shape, and color intensity of the crystals depend on factors like the cooling rate and the purity of the bismuth used. The slower the cooling process, the larger and more vibrant the crystals. Just like with cosmetics, it is crucial to use high purity bismuth. However, due to the handling of molten metal and potential safety hazards, it is important to approach bismuth crystallization with proper caution and under supervision, especially for young learners. I exclaimed, "The colors on the crystals are amazing." Bismuth added, "Yes, they are. That is why bismuth compounds are often prized for their ability to create metallic finishes in pigments and paints." We had reached the aisle where over-the-counter medications were neatly organized on shelves. Albert excitedly pointed to the array of medications in the laxatives and antacids shelf, explaining how his mom was prescribed one of the medications for stomach issues. Bismuth beamed, picked up a bottle, and held it up, prompting me to explain. "Your dress matches this medication bottle perfectly." I knew I had seen it somewhere. Bismuth nodded and shared that she wears it when teaching students about bismuth. Albert then asked, "How does this medication alleviate stomach issues?" Bismuth explained, "The active ingredient, bismuth subsalicylate, treats gastrointestinal discomforts like diarrhea and indigestion by aiding fluid absorption, reducing inflammation, and neutralizing excess stomach acid. I'm glad it helped your mom." Exo then asked, "Can we extract bismuth metal from this medication?" Bismuth smiled and replied, "Yes. Extracting bismuth from these medication tablets involves several chemical steps. Step 1. Grind the medication tablets into a fine powder to increase surface area. Step 2. Mix the powdered tablets with hydrochloric acid to dissolve the tablet components. Step 3. Filter the resulting solution to remove insoluble particles. Step 4. Add a base such as sodium hydroxide to the filtered solution to precipitate bismuth hydroxide. Step 5. Filter the precipitate of bismuth hydroxide from the solution. Step 6. Heat the bismuth hydroxide to convert it to bismuth oxide. Step 7. Finally, reduce bismuth oxide using carbon, such as charcoal, at high temperatures to obtain metallic bismuth. This process requires proper equipment, safety precautions, and chemical knowledge. As we walked towards the store exit, I voiced my confusion. "I checked the periodic table earlier and noticed your atomic mass is 208.9 AMU, categorizing you as a heavy metal. Aren't heavy metals dangerous and potentially radioactive?" Bismuth explained, "Many heavy metals have unstable isotopes that can be radioactive. For a long time, scientists thought all my isotopes were stable. However, in 2003, scientists discovered that bismuth 209 has a radioactive half-life of over 20 billion years, longer than the age of the universe. Bismuth 209, despite being radioactive with an extremely long half-life, is not considered dangerous to human health. Its decay process primarily involves emitting alpha particles, which are relatively large and low energy compared to other types of radiation like gamma rays. Alpha particles cannot penetrate human skin and are stopped by a sheet of paper or even clothing, making external exposure minimal and posing little risk to health. Therefore, while bismuth 209 is radioactive, its natural abundance and the type of radiation emitted make it non-hazardous in everyday contexts. Bismuth paused, then pulled a periodic table from her unique handbag. She pointed to Bismuth and asked us to look at her neighbors in the same period, starting from mercury. As we read aloud the elements, mercury, thallium, lead, and polonium, Bismuth remarked, "Do you see that I'm situated right in the poison alley?" Surprised, I replied, "Wow, yes, it is amazing that you're not toxic unlike your neighbors." Bismuth proudly continued, "Pigments and paints that once used toxic metals like cadmium are now using bismuth. And in alloys where lead was common, bismuth is now being used, making them much more environmentally friendly." Exo inquired as she eyed Bismuth's unique handbag. "Your handbag is quite unusual. Does it have a special significance?" Bismuth playfully twirled her handbag and explained, "It is actually modeled after a fire sprinkler head. These heads utilize alloys with low melting points, including metals like bismuth, tin, or cadmium. When the alloy reaches its melting point from the heat of the fire, it prompts the release of pressurized water in the sprinkler system, swiftly mitigating the fire to minimize damage and enhance safety." "Any other applications or cool facts?" Albert inquired. Bismuth responded, "Due to my relatively weak electrical conductivity or high electrical resistivity, I am prized in the semiconductor industry. I replace toxic elements like lead and antimony in semiconductor applications, making them safer and more environmentally friendly." Despite being rare, even small amounts of bismuth can significantly influence semiconductor materials. And here's a neat fact: I am diamagnetic, which means I repel magnetic fields. Her phone beeped suddenly and she exclaimed, "Oh no, I'm late for an appointment with some pharmaceutical students. Keep researching about bismuth." With that, she hurried off. We expressed our gratitude to her and soon found ourselves back in my home with the electron bounding happily around us. Over cookies and tea, we enthusiastically recounted our adventure to my parents. After bidding farewell to my friends, I retreated to my room to illustrate bismuth with vibrant colors. There you have it, the story of bismuth, from the magical periodic table and the Element Girl CD's Book 5, Family 15, the Pnictogen family. Happy learning! Thank you!